This is CPM Precalculus, Chapter 3, number 13. Triangle PAT is an isosceles triangle with side PA equal to TA. So here's the triangle. We see PA here. This side is congruent to TA, right? This hash mark right here shows that those sides are equal too. In fact, this sketch here, the drawing of triangle PAT, shows us it's not just isosceles, it's a right triangle, right? So it's an isosceles, let's put right triangle, all right? Part A says find the exact length of side PA, all right? Because we're given the hypotenuse, right? We're given side PT is equal to 8. And in fact, I'm going to relabel these. If this is A, I'm going to call this side little a. If this is T, I'm going to call this side little t. And this side, this angle is P, this is going to be little p. And I know P is equal to T and T is equal to P, right? Just like we're told. So we want to find the exact length of PA. Well, PA we know is right here, which is side T, okay? So let's go ahead and do this. One way to do this would be to use the properties of special right triangles. Because if you look at this triangle, if this is 90 and these are equal sides, we know right away that these two angles, if they're looking at across from congruent sides, then those angles are also congruent, right? And if they're congruent, well, we know this angle plus this angle here plus 90 degrees is equal to 180. And the only way for that to be true if these angles are equal is if they're 45 degrees each, right? So this right here is a special triangle. It's a 45, 45, 90 degree triangle. 45 degree, 90. And a 45, 45 degree, 90, a 45, 45, 90 degree right triangle we know has sides A, and this side right here is square root of 2 times A, right? So that is just a property of a 45, 45, 90 degree triangle. Well, instead of using that, I'm going to do a different way to find the exact side length of PA. If you want to use this method, you can, but I'm going to use Pythagorean theorem. Right? Pythagorean theorem is c squared is equal to a squared plus b squared. And the reason why we're able to do that is because we have a right triangle. We're given the hypotenuse. Remember, c is always the hypotenuse. Even though the labels are different here, we know here c is the hypotenuse, so that's 8 squared. And we know these two sides are equal to each other, so I'm going to just go ahead and call them both t squared, right? Well, then 8 squared is 64. T squared plus t squared is 2 times 2t squared, right? Divide both sides by 2, that's going to be 32 is equal to t squared. So I get t square root both sides. And I get t is equal to the square root of 32. Now, normally I would just pull up my calculator and go, well, what is the square root of 32, right? Square root of 32. But if you notice, we get a long approximate answer, right? That's not exact. We want the exact length. So we want to keep it in the form of square root of 32. But let's go ahead and simplify that. We know 32 is equal, so t is equal to square root of 32. And we know 32 is equal to 16 times 2, right? And we know the square root of 16 is 4. So in simplified terms, the side length PA is, or t, is just 4 square root of 2 units. Okay, and that's PA. Okay? And that's exact, right? If we went in our calculator and checked, well, 4 times the square root of 2 is going to equal the same thing, and it does, but that's going to be the approximate answer rounding in our calculator. Here we have exact. Part B says, what is the exact value of sine P, right? Well, let's go ahead and mark on our triangle. We know this side is equal to 4 square root of 2. This side is the same thing, so it's also 4 square root of 2, isosceles. We have this side is 8. So sine of angle P, we know from SOHCAHTOA that sine is the opposite side over the hypotenuse side. So sine of P is the opposite side of P. So that's going to be this side, which is 4 square root of 2 divided by the hypotenuse of the triangle is 8, right? It's always the longest side, and here it's 8, okay? So simplifying that, we get 4 over 8 is the same as 1 over 2, square root of 2. And we can just write that as 1 times square root of 2 is just square root of 2 over 2. All right? And this is a ratio, so there are no units. We don't write units. Sine is a ratio of a side to a side, so there are no units to this. Okay? All right, let's go on to part C. C says, what is the exact value of cosine of P? Well, we know cosine is adjacent over hypotenuse. I could write that. Adjacent divided by hypotenuse. So given P is here, the adjacent side is this side right next to it, which is also 4 square root of 2. The hypotenuse is 8 no matter what in this triangle. So again, we get 4 square root of 2 divided by 8, and we know that's square root of 2 divided by 2. And no units. This one has units because it's a side length, but the ratios, cosine, sine, tangent, cotangent, cosecant, secant, these are just ratios of sides, and they do not have units. So this is the exact value of sine of P and the exact value of cosine of P and the exact value of the side length PA. And that's going to end for our CPM Precalculus Chapter 3, number 13.